Baggerman, and is Sven coming up too? Sven Huisman? Cool, he's being fitted. Their session is Tales from the Dark, and it has to do with EUC performance, so I'm really interested in where it came from. Last year, Kees kind of broke our whole presentation system, and I figured maybe that was the nuance to the dark there, but I guess we'll find out. So thank you, Kees and Sven.
Yeah, this year we're using Ruben's laptop, so I'm not breaking the AV system again. Sorry, AV guys. I brought you coffee to apologize from last time. My name is Kees Baggerman. If you want to, I'm a technical director within Nutanix, and my team focuses on end-user computing, on both collateral, on technology, on a little bit of marketing. Luckily, we've got Ruben, who's great in that. And I'm together today with Sven.
Yeah, my name is Sven Huisman. I work as a solutions architect for Nutanix, and part of my job is actually to run performance tests for input for our reference architectures, but also for improving the performance of running EUC workloads on Nutanix. And actually, this year is my 10th anniversary of using Login VSI as a performance tool, so
quite experienced.
I have a little bit of experience. So.
Right, so about this session, we wanted to start with the key takeaways. And our key takeaways are basically fast, good, or cheap, and pick two. And it's the everlasting kind of struggle that we're in. It can be really fast, it can be really good, but cheap isn't an option there. Or it can be really good, probably cheap, and not so fast. So you need to kind of balance that out. And hopefully this session will give you some guidance in towards we think you should look at to kind of navigate around that struggle. So how to get best performance? And we looked at it and we took a step back and looked at what is performance. And not just UX, but overall performance of your infrastructure. So one of them is user experience, which is crucial to any deployment, but also cost, manageability, security, and support. And we basically took those items and we measured against some of the valuable metrics that we think we should use in the field to actually get the best performance for your end users. So let's start with optimizing your golden image. And I'm sure most of you do this on a regular basis, but let's start with the why. Right? It's improving user experience by reducing resource consumption. And resource consumption on CPU, which is typically a boundary in the work that we do, in the field that we do, on I/O, on memory. But the most important thing in optimizing your image is know what you're doing. Right? There's a bunch of tools out there that can help you. There's a couple of documents that can guide you through the options and why you would do some of these optimizations. Read them. Don't just run the tool. Understand what you're doing because it might impact your application behavior. How? Start off with disabling scheduled tasks and services that you won't need. If you're not using OneDrive, just remove it from your golden image because it will consume up a lot of unnecessary resources. I've seen logons taking 3 minutes because OneDrive wasn't configured properly at setup. And if you don't need it, this particular customer was using a different enterprise file system called Citrix ShareFile or Files or Content Collaboration or whatever it's called today. Remove Windows Store apps if you don't need it. I still have to come across the business unit that has Candy Crush as a line of business application and validated. Create scripts with these optimizations. So make sure that you run these optimizations in a scripted, programmatic way so you know that they're applied each and every time. And we'll go in a little bit deeper later on why you should do this. And there are tools out there that can help you. Right, there's a BP Analyzer, which is a community project, but also Citrix has a fully supported optimizer. It's available on their portal. And then there's the VMware OS optimization tool, which is a fling, which means that it's not fully supported, but VMware is putting it out there, and there's active development on that fling. Now, optimizing the image, we've got Sven, who has 10 years of experience with log and VSI. So he's basically my lab assistant, you know, the guy with the fluffy hair and the rat. That's Sven. He goes out and do all these tests. So we did testing with no optimizations at all. That's our baseline. That's our benchmark. Now, what happens if we do an optimized V1? And I'll get a little bit deeper into V1 later on. We saw an improvement of desktop density per server or per node of 84%, which means that 48%, sorry. So that means that if you don't optimize, you're leaving 48% performance or density on the table, right? So that's a big chunk. So make sure you optimize because it will impact your density and the cost of your environment, and also user experience. Now, we also tested with optimized V2. What did we do there? We basically tested with a new template of the optimizations. So what does this tell us? It tells us that the operating system and the optimizations out there are constantly evolving. So you can't just stop with doing this once. This needs to be embedded in your process. So if you're adopting a new version of Windows 10, which you will, because it's being force-fed, rerun these optimizations and check if there's a new template available. On the app responsiveness side, again, same benchmark. No optimizations is 100%. That's our baseline. When we run the optimizations, we see that applications are responding 5% faster than before the optimizations. So it's not just user density, it's also impacting user experience. And with the V2, we saw a 9% increase. So the better the application responsiveness is, the better the user experience is. So make sure you optimize your golden image because it will impact both user density and user experience. So the pros, again, better user experience, higher densities. The cons, basically you have to redo your optimizations with every Windows feature release or application release. And you have to know what you're doing because you might break stuff. So from a user experience, cost, manageability, security, and support perspective, this is what we think would be the balance. So better user experience, it's good for cost. Manageability, you have to rerun this every single time you update your Windows 10 or your 2019 versions. So it's a little bit more difficult to actually manage. Security is kind of in between. And support, we put that into the amber-like color. I'm partly colorblind, so Sven did all the colors. So I assume it's amberish. Support was amber because some of these tools are not fully supported, like the VMware OS optimization fling. It's a fling, so it's not fully supported.
So another thing is keeping Windows up to date. Is that a good thing to do when you want the best performance for your VDI environment? First of all, let's take a look at what's the support statement of Microsoft. So depending on the version and the edition you select for Windows 10, Microsoft releases 2 times a year a new feature release of Windows 10, and the release is supported for 18 months or 30 months, depending on the edition. So what happens when you run out of support? You will not receive security or quality updates, and of course not getting support from Microsoft as well. So if you look at this chart, then you see that there's an overlap in support. So you could actually skip 3 versions of feature releases before you continue to the next one. So from a support perspective, you could easily skip a couple of versions. If you take a look at the performance of each version, then the question is it wise to update to every new version, or do I want the best performing edition of Windows 10? Well, when I did the performance test back in 2018, October 2018, then the differences looked a little bit like this. And the Windows 10 1903 version was, at the time, was an insider preview release. So maybe that's not very realistic to represent here, but in December 2019, I did the same tests again with the updated version. So there were new patches applied, new security updates, maybe vulnerability patched. And I saw a decrease in density with almost every version. So if you look at the additions, if you go to a newer edition, your density will decrease, but also if you update your Windows 10, most of the times your density will decrease as well. So from density perspective, you could say, well, it's better to stay on an older 1709 version, then I get the best performance. I won't have to buy new hardware to support the same amount of users. But then again, you don't get the security updates and the support, right? Also, from an application responsiveness, we see a decrease in performance for the applications. So the user experience is also lowering with every new release of Windows 10. And also in December 2019, I saw another decrease in performance of the application responsiveness. So in summary, updating to a newer version every time for Windows 10, well, it's more secure. You get the security updates. You have longer support if you select the right version. And you are able to use new features of Windows 10 if that is the case in your VDI environment. The consequences are, of course, lower density. You might require newer hardware or new hardware to host the same amount of users. And the application responsiveness is lowering with every new release up until now, at least. So user experience is not good to keep your Windows up to date, I would say. The costs, you will need more hardware. Manageability, you will have to create new golden images every time. You have to test all your applications on every new feature release. And for security, it's of course better to keep up to date your Windows and also for support.
Right, so one of the questions that we get a lot from a customer perspective, but also from a partner perspective, is what happens if we use more vCPUs? So what happens if we solve the problem by just smacking more hardware at the problem? Now, we did some testing there, and obviously we went from 2 vCPUs to 3, et cetera, et cetera. And this is just pure on density. So what we saw was the offset. Again, 2 vCPUs is our baseline, that's our 100%. And we added 1 more vCPU for the desktops, and we got 88%. So we lost roughly 12% of density by adding 1 more vCPU. When we went to 4 vCPUs, we lost 19%. So who would expect that going from 2 to 4 vCPUs would only take 20% instead of 50%? Nobody? Just a few, okay.
That is using the same workload, of course.
Obviously, it's like for like, same infrastructure, same hardware platform, same log and video type versions. It's a like for like test. Reason here is that CPU schedulers in the hypervisors are pretty intelligent these days. So it doesn't, like, upping your vCPUs by 200% doesn't cut your density in half, which is a good thing, but it's also something that we have to keep in mind. If you're sizing right now, you might be sizing for 2 vCPUs, but who remembers the days when we sized for 1 vCPU? Who does 1 vCPU today? You must really hate your users, right? So keep that in mind, right? There's a trade-off in terms of adding more performance versus the density you get per node. Now, looking at the same angle for an app performance or app responsiveness perspective, again, 2 vCPUs is our benchmark. Adding 1 vCPU adds 5% of application responsiveness. Going to 4 vCPUs, we saw 6%, and going to 5 CPUs, we saw 7%. So maybe that trade-off between 2 vCPUs and 3 vCPUs, that 12% decrease in density, actually is a good trade-off because we get 5% additional application responsiveness. It's not a choice I can make, but it's definitely something that you can talk to with your end users or your customer base. So looking at the same angle again, the pros are better application responsiveness, which equals to happier users, But obviously, there's a con because you'll lower the density and you'll have a little bit more of hardware. But there, again, it's that trade-off that we talked about, and maybe it makes sense for you to do to add more vCPUs.
So vulnerability mitigations. It was also in the introduction of today, Spectre and Meltdown. It's been almost 2 years ago since those vulnerabilities were announced or made public, and at that time, the vendors started to supply us with patches. So it were hardware vulnerabilities, and we got software patches to fix those vulnerabilities, right? And especially those software mitigations to hardware vulnerabilities can impact your density in VDI environment a lot. Because a VDI environment is, of course, CPU intensive, and when your workload is CPU intensive, then these kind of mitigations can hit your density extra hard. So if you look at the density with all the mitigations applied, and we compare that, I say here, all the mitigations, that is Spectre, Meltdown, and the Foreshadow, or L12F, then you can gain up to 40% of your density back if you disable those mitigations. So we're here at the VDI Performance Summit and not at the VDI Security Summit. So from a performance perspective, I would say, yeah, well, let's disable all those mitigations, right? So we can host a lot of more users on the same hardware.
Have a good conversation with your security team. Yeah,
right.
That sounds smart.
Right. Well, at least you can have a discussion of from whose budget is going to be, right? So, and also if you look at the application responsiveness, we see roughly around 10%, depending on the workload and the CPU type, 10% better responsiveness if you disable those mitigations. But not all mitigations can have a negative impact. This was released 2 weeks ago. It was announced by the NSA. And if the NSA tells you to patch your Windows 10, then they probably already in your system, right?
Did they also advise to shut down Citrix?
No. That was the Dutch government, right? So I've tested this patch as well. So I compared the December version of Windows 10 1909 with the January 1909, which included the patch, and I saw an increase in performance, or in density, and also in application responsiveness. So not every patch or security patch has a negative impact on your performance. It's especially the software mitigations against hardware vulnerabilities that will hit your performance in your VDI environment. But back to the hardware vulnerabilities, would you disable those mitigations or not? Well, from a security perspective, of course not, because your security is at risk at that time, but your density is higher and your users are probably more happy also because the application responds faster. And also, from a support perspective, some vendors don't support you to disable those mitigations, so that's something to consider as well. But maybe in a black site where there's no internet access for the users, then you might consider this, maybe.
Or maybe even a more hybrid approach where you kind of weigh off the risk versus the balance or the user density, right? I mean, some of the customers I talk to, they consciously take the decision to do Spectre Meltdown patching, but they don't do L1TF because, I don't know, because they weigh up the chances that they get hit by that vulnerability.
Yeah, it's a risk assessment. What are the odds or the chances that you are...
And how friendly you are with your security team as well, I guess. But that CVE, so if you have Windows 10 right now and you're not patched, please do so if you have a free moment, because it will gain security and performance. So it's a win-win situation, I guess.
Yep.
If you want to have that conversation with your security team around Spectre, Meltdown, Foreshadow, you have to give them a little bit too. So installing that CV kind of makes sense. Now, it is the VDI Performance Summit. And with me coming from an engineering background, working with marketing, this is like my day-to-day conversation I have. People using VDI as a catchphrase for everything, while RDSH or XenApp or any of those multi-session roles is still a big part of the work that we do. So in this assessment, in these dark tales, we see people shifting to VDI because they heard it on the golf court or maybe on a marketing event. Maybe RDSH would be a good solution for them based on the parameters that we just discussed. So let's look at densities again. We tested VDI, Windows 10, and we compared that. That's our baseline. That's our 100%, and we compared that to RDSH. And as you can see, there's a big gap in density. So RDSH is actually more efficient in terms of user density than VDI. It's not just a few percent, right? It's a pretty big chunk. So if you have a large install base, it means that you probably need less capacity to actually host the same users. Now, what would that do on app responsiveness? Again, VDI is our baseline. And we saw that app responsiveness on RDSH, it's actually better. So performance shouldn't be a key metric when you decide for VDI or RDSH or multi-session, whatever you want to call it. It might be different items, but we see that you get higher densities and better performance with RDSH. Looking at the pros and cons, better application responsiveness, so you should have happier users. Higher density, so lower cost, which is a good thing from an IT perspective. The cons, limited use cases perhaps. Power users you probably don't want to have on your RDSH environment, right? You probably want to contain them into their own VM so they can consume all the resources they want, but they're not affecting everybody else. Luckily, there are solutions for that in terms of segmentation, in terms of resources. Another con could be support. Who has applications that are not supported on a server OS? We still have them, right? It's not uncommon for people or application vendors not to support a specific server operating system. So looking at, again, the balance in these key metrics, we see that user experience is really good in favor for RDSH. Cost is really good because we need way less equipment. Manageability, same. Most of these brokering solutions will have both RDSH and VDI in the same management console, so you're not shifting gears all the time. Security could be the same. Could not be the same, but it depends. So we took security as a perspective that if you're securing a Windows guest operating system, you should be securing a Windows server operating system as well, right? Doing the security settings here probably once you validates to do the same security settings on the server side. And support a little bit in the red because not every application will support server operating systems.
So we've seen a couple of things that can impact your density and also your performance, your application responsiveness. One thing you could consider is to upgrade your hardware. So I've tested Broadwell versus Skylake versus Cascade Lake CPUs, using the same desktop image, using the same workload. The only difference is the number of cores and the gigahertz per CPU, so the speed. So those are not actually the same, but from a pricing perspective, these are the CPU types that we see with task worker, knowledge worker workloads. And actually the Cascade Lake was the cheapest CPU at time of release, compared to the other two. But let's take a look at the density differences between these three CPU types. So we see from Broadwell to Cascade Lake, 70% increase in user density. Well, it has 4 more cores, so that's like 20-something percent, 25% more cores, but it's 70% more density. So it's actually performing a lot better. And also, if you look at application responsiveness, the newer processors will improve your application responsiveness as well. So
The reason we looked at this, and one of the reasons that we think the performance is better is because of the memory bus. So with newer CPU generations, you would get faster access to the memory bus, and that leaves more room for CPU cycles. And we've seen this going on as from Ivy Bridge to where we are today.
Yep.
And Cascade Lake supposedly has some hardware mitigations against
some of the Spectre meltdown.
the Spectre meltdown as well. So you're not relying on that software translation anymore. You have it right on the chip.
Yeah. So, of course, better application responsiveness, higher density, so you have less hardware to manage. And, yeah, well, security and support, maybe sometimes an application is only supported on a certain newer type of CPU, so maybe that should be green as well. But overall, the user experience is better, only it will gonna cost you new hardware.
And another topic that we talk, or I talk about, and T-Pop, are you in the room? No? Thomas Poppelgaard would talk obviously about GPUs because that's his bread and butter. But adding GPU hardware acceleration impacts your user experience as well, obviously. But it affects all the other items as well. So it's something that you have to keep in mind. This comes from a report that Lakeside released, and it's an older report. It's 2017, but it's one of these graphs that I typically show to customers because based on their research with the move from Windows 7 to Windows 10, they did customer surveys, and it's a marketing slide. So I think realistically, we're able to do good performance without a GPU, right? We'll be somewhere between high-end fair and mid-range good in terms of what we can deliver without a GPU. Obviously, if you want to have excellent user experience, GPU could be an addition to that tool set. Do I think that GPU is needed for everyone? Personally, I don't think it's needed for everyone. I think you should look at the right use case, and it adds a couple of things that you need to keep in mind as well. Right, so if we look at the pros and cons, most often you would have better application responsiveness, right? You can do GPU offloading, so the GPU is taking care of the encoding, decoding of the packages, which means happier users. Or you might extend to a new range of workload, having 3D or graphic intense workloads on the platform, which opens up talent acquisition and all that. So that might make sense. The obvious costs or the obvious cons are lower densities. Because of the density per board that we can get on a GPU, it's not fully in balance with what we can achieve with CPU. Right? So if I take the T4 for example, if I fit a server with 4 T4s, I can fit 64 users on that board or on that server. Well, maybe if I don't use GPUs, I can get 100, 120, 150 users on that same server, but just not GPU enabled. So there's a difference in density. Obviously, NVIDIA comes with a little bit of a price tag, not so much on the board itself, but licensing might be a thing. It's something that you have to discuss with your NVIDIA counterpart. Yitz is here, so if you're interested, NVIDIA is here. And there's more to manage. Because like you saw in the first image on GPU, we're adding a couple of components to actually deliver that GPU capabilities. It's drivers, both on the hypervisor side, on the guest OS side. You need to keep that in balance for the best performance, but also support. And there's licenses involved as well. And previously, FlexLM wasn't my favorite licensing server. So from that same perspective, again, user experience is good. Cost, not so good. Manageability, we're adding components, so that means more to manage. Security, we're kind of neutral there, and support is good because you get access to a couple of more applications that you can probably supply via your platform.
And attached to that subject is display protocol. So there are a couple of different vendors that have their own display protocol, or maybe they used another one's protocol, because VMware, for example, with VMware Horizon, you can use PC over IP, you can use BLAST, you can use RDP. And with every protocol, you can tweak or tune certain settings. So what's important to realize is that choosing a protocol or even tweaking within a protocol will impact your user density and also your performance. So I'm not going to do a bake-off between different vendors. Look, this one is way better than the other when it comes to density.
We're not starting off protocol wars. That's why we have Rodi.
Yeah, Rodi is in the back. He will, or he was in the back. But I've seen density differences from 40, sometimes 50%. So just by selecting another display protocol, right? So if you're not already selected a product, be aware that using a certain protocol can impact your density as well. So you would need more hardware if you used one protocol over the other one. And this can also happen with tweaking settings. So
or maybe add GPUs because it's H.264 encoding and it's better on a GPU than a CPU, which adds cost by itself.
So pros and cons, it depends. Do you want the best user experience? Then you tweak your display protocol so it will maybe use more resources or maybe even needs a GPU. And it's gonna cost you a lot of money. Or you tweak your user experience in a way that it's workable, but frame rate is low, the quality is maybe lower than you could have, but you lower your cost. So it's a trade-off between those two, right?
Yeah, so to summarize all of this, we talked about cost, about performance, and about supportability. Again, which one would you pick, right? It's always a trade-off. So keep that in mind in your internal discussions, in your customer discussions, maybe just between peers, that you can't have all three, which is a shame, but it's just the status quo as it is today. So with that, we'd like to thank you for your time. For questions, we'll be right outside, and we hope you have a great day. Thank you.